Hi guys, my name's Raz and today we'll be looking at parametric integration. So for this video, you will need to know how to be able to integrate and use limits and change limits and how to integrate this sort of thing. So if you can't, then watch one of my other videos first, then come back to this one. So parametric integration, how does this integration work? How does integration work with parametric equations? Quite simple. We're given x is a function of t and y is a different function of t, then the area or region of space R is equal to the integral of y times dx by dt with respect to dt. Yeah, so make a note of that and we'll go straight into an example and use it. So worked example number 1, we have the function x equals t cubed and y equals 4 minus t squared. So the first thing to do is figure out dx by dt. So dx by dt would be 3t squared. And let's write down what y is, 4 minus t squared. So from the formula you can see in the top right-hand corner, we just need those two things. So R must be the integral of 4 minus t squared times 3t squared dt. So next point would be to figure out the limits. If I expand the bracket, we simply need 12t squared minus 3t to the power 4. So now we need to change the limits. Changing limits, because these are x values and we want t. So if x equals t cubed, it follows that t is the cube root of x. So we have t equals the cube root of 8 and t equals the cube root of 0. So our limits will be 2 and 0. Yeah, so this will integrate easily enough. So we're going to have 12t cubed over 3, which will be 4t cubed, minus 3t to the 5 over 5, between the limits of 2 and 0. So we have 4 times 2 cubed minus 3 times 2 to the power 5 all over 5. Take away 0. And that will equal something we can put on the calculator. So we've got what? 8 times 4 is 32. 32 times 5 is 160. 32 times 3 is 96. So we've got 64 over 5. Let me get rid of the note from my sponsor. And we have 64 over 5. So that is worked example number 1. Write that down, pause the video, write that all down, and then give this one a go. So the summary of what we've done first. We wrote down the integral in general terms. We changed the limits from x to the parameter. We found dx by dt. We put the integral in terms of the parameter. and then we integrate it. Yep, so now pause the video and give that one a go. Welcome back. So we have x is cos 2 theta. So dx by d theta equals -2 sine 2 theta. So y is equal to sine theta. So we need to find r, and that is equal to y times -2, I'm going to put -2 there, sine 2 theta. Well, I think you saw me probably pause a second ago because I was thinking, oh yeah, how do I do this? Well, if you look at your rules, you know that sine 2 theta, let me write in the bottom corner, equals 2 sine theta cos theta. So we go, the issue is we have a theta and a 2 theta, so we need to make them the same. And so we get 2 sine theta cos theta. So our integral is now -2 of -2 times another 2, so -4 of sine theta times sine theta and cos theta. Haven't changed the limits. Need to do that. So we have x. You make the line a bit thicker. So if x equals cos 2 theta, it follows that theta will be cos inverse of x divided by 2. So I'll just place my calculator. Yep, so if we do cos inverse of 1, I don't need to calculate for that, that is 0. Let me do it in colour. And if we do cos inverse of 0, we get pi over 2. Yeah? But I still have to divide that by 2. So the answer will be pi over 4. And now we need to integrate this bit. I'm going to go on to a different page for that. So if we're integrating, on the side, if we integrate sine squared theta cos theta d theta, this is what will be known as in the textbook as reverse chain rule, essentially, but we could essentially do it by substitution. If we notice, if I rewrite it first, this is sine x squared times cos theta. So there's a relationship between this and sine x. So if I did a substitution, it would cancel out. It would end up just integrating to sine x cubed over 3 plus c. I've not done that in too much depth because there's another video called reverse chain rule, so you can check that out there. So the integral will be sine x cubed over 3. So when we go back to our previous bit, I've somehow cleared all my work. We would have ended up with the integral of sine cubed x over 3 between 0 and pi over 4 times by minus 4. So we've got minus 4 lots of sine 0 minus sine pi by 4 cubed over 3. Well, I didn't put the sine x cubed because we know, sorry, sine 0 cubed, because we know that will give us 0. And sine pi by 4 will be root 2 over 2. So what we have is minus 4 lots of root 2 over 2 cubed times a third. So root 2 cubed is 2 root 2. And minus 4 times 2 root 2 all over 2 cubed, which is 8, times by a third. Again, just get rid of this note from my sponsor. So that was an 8. So that will be minus half times 2 is minus 1. So just end up with minus 4 times minus a third root 2, which is 4 root 2 over 3. Yeah, I hope that's made sense. Check out my website, rasmas.com, for some more questions. See you soon.